Hey guys, this is Kevin aka Dricklin on the Esenthel forums, and today I'll be showing you a new addition to the EEDevTools project I started a few months ago. So after I finished the first tool of EEDevTools, a developer's console, I was trying to figure out what to do next. After going over a few different ideas for brand new tools, including a debug and visualization tool, I decided to go in a different direction and completely rewrite a tool I made for Advocate, a previous game project. The tool was an events editor, only it wasn't well written, had very many bugs, was difficult to use, and was not designed to work with any game other than Advocate, a major problem if I ever wanted to release the source code publicly. Well, now all that has changed. The tool has been completely rewritten and will work with any game world, whether it be small or large, and it allows you to assign events to nearly all standard world editor object types, as well as any custom object type your game may use, provided that you implement them properly. The events editor in the included sample project does not use any scripting language. It is a pure C++ implementation, so there's no need to learn any new languages. Alright, so let's go ahead and do a quick preview of the included sample project and showcase some of what the event system can do. As you can see, in front of me I have 3 different characters and 2 different items, a barrel and a missile. Let's see what happens when I walk up to any of these 5 objects and look at them. As you just saw, the object you are looking at glows blue, and a message is displayed at the bottom of the screen stating to press R to swap skins. Let's go ahead and do that. Awesome, but will it also work on the items as well? Sweet, a walking barrel. So how does it all work? Well, it's simple really. The event system is a complete bare bones. That is to say, there are no predefined events. What this means is that you must first define your own events that then subsequently trigger certain functions under the right conditions. For instance, when I look at this object, several things are occurring. First, the event system executes a function that checks to see if I am looking at one of these 5 objects. That is because I have told it to do so. If it turns out to be true, it then executes 2 other separate functions, both of which I have manually defined. The first, which sets a flag telling the character or item to glow, and the second, which sets a flag telling the game to display the message. There's a bit more to it than that, but that's pretty much the gist of it. If you would like to see more of the sample project, please download the EEDevTools library on the Esenthel forums. There's a link below in the description. Now it is time to look a little more in depth as to how to set up your game to use the event system. As a reference, I will use the world from the included sample project. You will need to use the world editor to define the objects the event system is allowed to access. To do this, you will need to add a string parameter called actorID and assign a unique name to each and every object the event system is allowed to use. This is required because without this information, there is no way for the event system to know which events belong to which actor. I will now quickly show you how to do this. After selecting an object, click Add Param, change the parameter type to string, call it actorID, and assign it whatever name you feel fit. Here, I will name this object player. Be sure to do this for each and every object you wish to use within the event system. After you have finished adding the actorID parameter to all necessary objects, you will need to switch to the included tool called Events Editor. This is a tool that enables you to create an individual timeline of events on each object. These events will then be later loaded into your game and executed by the event system. The first time you load the tool, just like in the Esenthel editor, you will need to set a data path. Here I will choose the default data folder for the Esenthel Engine. After setting the data path, you will be prompted to load a world. But before you do this, however, you should make sure that there is a file named events_type.enum.h in the enum folder. This folder is detected in relation to the folder containing the world you wish to load, not the data path you have already set. Here's an example of what I mean. The events_type.enum.h file contains a single enum named event_type. This enum is dynamically loaded into the events editor at runtime whenever you load a world. Here's the contents of the file. If you are not loading the sample world but your own, you may simply copy this file to the correct location and edit it freely however you like. Now we are ready to load the world. After the world has loaded, you may begin to create or edit your event timelines on any object that contains the actor ID parameter. To do this, simply left-click on the object, hold the spacebar to pan the camera. The timeline for that object will appear and load all events currently assigned to it. Events consist of an event type, a function name, and a target. To add or remove a target from a selected object, simply click and hold the right mouse button over the desired object and release. Later on, during the coding stage, you will create a function for each individual event type. These functions are known as event type functions and are responsible for determining if their respective event type has occurred. Just like for event types, you will also need to create a function for each and every unique function name that you've assigned to your events. These functions are known simply as event functions and are triggered by the event system when the event type of the current event has occurred. There will be more information regarding event functions and event type functions a little later. Events are executed from left to right order as they appear in the timeline. If you need a certain event to execute earlier in the timeline, simply click the left arrow underneath the event to move it to the left. Likewise, if you need that event to execute later in the timeline, simply click the right arrow. If you need to remove an event from the timeline altogether, simply click the X button. If you ever find yourself having to create the same event on more than one object, you may use the copy and paste buttons to help speed the process. If you ever have multiple objects that use the exact same timeline, you may copy the entire timeline from one object and paste it onto the other. This can be a major time saver if you are dealing with an extremely large world. When using the editor for your own game, there is one thing to keep in mind: active range. Active range defines how many areas of your world is loaded at any given time. The higher the number, the more areas that will be active. It is best if you set the active range for the editor to be the same as the active range of your world. The default value for active range is 100. It is important to set your active range accurately because if one object targets another object that is no longer in the active range, the event system will be unable to successfully execute the events that target that object. Why? Because if object B is outside of the active range of object A, it means that object B no longer exists, and therefore object A will be unable to target it. Here's a quick demonstration to explain this concept a little more. As you can see, this object targets another at the far edge of the active range. The active range is indicated by the white outline drawn in the world. Let's see what happens when I decrease the active range. An orange box has now appeared around the object. This indicates that it contains invalid data, more specifically, in this case, meaning that the object is targeting another object outside of its active range. I should either increase the active range or remove the data altogether using the Remove Invalid Data menu option. An alert appears indicating that the world contained invalid data and how much of it was removed. Now you can see the orange box around the object has disappeared. All the invalid events have been removed from the object, as well as all invalid targets. This object now contains purely valid data. Now that you know the most important parts about using the events editor, it is now time to move on to actually coding the events. Let's open up the included sample project. While EEDevTools is written entirely within Code Editor, there are Microsoft Visual Studio compatible files ready to go in the CPP folders for all included tools. Let's begin by opening the main.es file in the event sample project. If you have ever used the developer's console, most of how this is coded should look familiar. The event system is coded in a similar way, however, it is a bit more complex and requires extra steps to fully function. While I'm not going to cover all the code line by line, I will, however, cover the most important parts. It is now time to tie in all the hard work we have been doing thus far. If you have been scratching your head over what exactly the event types or function names are for, this next part will hopefully answer all your questions. Let's look at this line. What this line does is creates a new event type in the event system called on_contains. And assigns the function onContains to be responsible for determining if this event type has occurred. Any event using an event type that has not been defined cannot be executed. If you recall from the events_type.enum.h file in the enum folder, on_contains is included in the enum. While this enum is required for the events editor, here only a string representation is needed. There is no need to load or use the enum in the sample project or your own game. If you've noticed, the rest of these event types are also defined in the enum. Similar to how event types are created in the event system, event functions must also be created. These are functions that act in response to an event type occurring. Event functions should be created for all the unique function names you've assigned to your events throughout your world in the events editor. For instance, here I am creating a new event function using the function name highlightMesh. All events using this function name will now be able to trigger the function highlightMesh whenever their event type occurs, as determined by one of the event type functions previously set. Any event using an event function that has not been defined cannot be executed. Before we take a look as to how to create event functions and event type functions, there are a few more important things you need to first understand about the event system. Because events are not meant to occur every frame, they are not processed every frame. In fact, events are only processed by default at 10 frames per second. Due to this, the event system has its own cache for keyboard and mouse input. This means that you should not use the standard KB or MS classes for detecting input inside of an event function or an event type function. The reason for this is because if the game is updating at 60 frames per second, but the events are only processed at 10 frames per second, some input may occur in between processing the events, but is no longer occurring when the events are actually processed. meaning that the events that rely on input detection may not be executed properly. To remedy this, be sure to use the events.kb and events.ms classes instead. Don't forget, you will need to specify which keys or buttons you need to be cached as well, as shown here. Now let's take a look at how to create an event type function. Open the file eventtypes.es. All the functions in this file define every event type available in the sample project. Event type functions can be created in two different ways. The first, void functions, which manually trigger the event function of the current event, as shown here. And the second, Boolean functions, which return true when the event type has occurred. All event type functions must accept at least one parameter named actor. This is the actor that the current event is being executed on. Void functions also allow for multiple actors to trigger the current event function simultaneously. For instance, the function onContains uses a collision callback struct that calls the method events.triggerFunc for every single actor that is colliding with the current actor. This is useful, for example, if you need to damage all enemies at the same time that are physically colliding with the current actor. We will now take a look at how to create event functions. Open the file eventfuncs.es. It contains all the event functions available in the sample project. All event functions must accept at least one parameter named target. This is the actor that the current event is targeting. You may also optionally accept one or two more additional parameters. The first, named actor, which is the actor the current event is being executed on. And the second, named sender, which is the actor that triggered the current event function to occur. Depending on the particular needs of your event functions, you may find these additional parameters useful. For instance, if you only wanted an event function to be triggered by a player object, you could check to see if the actor group of the parameter sender is equal to ag_player, as shown here. If it is not, return early to prevent the rest of the function from executing. Open the file objtypes.es. In order for the event system to successfully load the events onto the actors, you must first set which actor belongs to which actor ID. To do this, in the create method of your object classes, you will need to call the events.setActor method as shown here. This method will return the value of the actor ID parameter if found on the object. It is recommended to save this value to a member variable of your class so that you may access it later on. It is important to note that if your entire world is not loaded when the player is in any area at any given time, and if those unloaded areas contain actors that will be used by the event system, there are two extra things you will need to do. First, you must override the save and load methods of any object class that will be included in the game save. This typically includes objects like characters, items, and particles. You will need to save the actor ID to the file during the save method and load it back in from the file during the load method. Also, you must once again notify the event system about the actor. Secondly, in order to save and load events properly while the player is traversing your world must use a custom area data struct. In main.es, a valid custom area data struct has already been created for you. You may simply copy and paste this into your own game, and it should work flawlessly. You can set this struct to be used by your world by calling the world.setAreaData method as shown here. This concludes the video tutorial of the EEDevTools events system. Hopefully, you now know the steps necessary to take in order to integrate the event system within your own game. Depending on how well I made this tutorial, you may or may not have quite a few different questions that you need answered. Feel free to ask for support on the Esenthel forums. There's a link below in the description. Thank you for watching. If you made it this far, kudos to you. Good night, everybody.